And we are live. Okay, awesome. So, hello everyone, and welcome to GDA's Godot tutorial. This tutorial is aimed at beginners and people who just kind of want to learn Godot for the first time. The idea is that you can come into this tutorial with no prior experience and walk out of here feasibly with potentially your first game, right? So, without further ado, let's go ahead and get started. So we're going to skip some of the preface stuff that we would usually talk about a little bit more in detail in a general GDA meeting for the sake of time. But step one is going to be obviously downloading the Godot game engine. So if you can just go to the godotengine.org website. And then once you reach this website, there will be a button at the top of the screen that just simply says download. If you could just follow that link, I'll give a second for anyone who may be wanting to follow along. Okay, and once you've reached that point, you can download your respective version of Godot. Kind of an interesting thought piece here is that it's only about 36 megabytes on Windows, but for whatever reason, the Mac version is closer to like 70. It's double in size, which I mean, I don't know why, honestly, but notable fact, I guess. So once you download your appropriate version, I've also provided a link in the Hacklahoma Discord, or if you just like to, I don't know, if you just like pain, you can type that out by hand. That's fine too. But within there, you will find two different assets that we'll be using for this tutorial. The first one is just a little player sprite, right, that has a little run animation and a little idle stance, right, that we'll be using later on. And then the other one is just our simple tile sprites that we'll be using to populate our scene, so that way we can differentiate between just, transparent background and the terrain that we have to work with, right? So I'll give you guys just a few minutes to go ahead and get Godot settled into your computers and to get the assets downloaded. And honestly, with Godot, for those of you who might be kind of confused, right, usually you download like kind of an installer, and then that you would run through that process, right? Like for those of you who may have followed along with especially like Unity tutorials or Unreal tutorials in the past. But honestly, you'll just download a zip file, you'll unpack the zip, and you're good to go. So I'll just give a few minutes for people to finish downloading Godot, and for those of you who are downloading the assets. So I'll probably give, what time is it now? All right, I'll just give about, probably about 2 or 3 minutes, just in case anyone's working on slower connection.
Who made this for you?
Jared actually, yeah, Jared made both of these assets here, and I formatted the slides, but he's the one that actually came in and populated them with all the useful information. So yeah, he did a wonderful job with it. Yeah, thanks. Just kind of I don't know where I got the idea of like a laser theme. I don't know. I just associate lasers with Godot, I guess. I don't know. I mean, I guess we could, right? We'll just make some cool mirrors and just have them like reflect. It'll be a fun time. Yeah, I guess I could actually mention that for those who might not know. Kind of the goal at the end of this tutorial is that you will have a working 2D platformer. So akin to games like Mario, not necessarily Celeste or anything as complicated as that, but just a very basic 2D platformer, right? So I think I've given enough time by now. So you guys should hopefully have Godot downloaded onto your machines, and you should hopefully also have this asset pack. So we'll just go ahead and move right along. So yet again, this is just outlining what's within the asset pack, right? So the tile set, and then there's another folder with the actual tiles, right? And so this is where I should have paused and waited on you to download Godot. But I did that already. Yeah. Thank you. We try. So as I mentioned before, once you download Godot, you'll have this .zip file. All you're going to simply do, and I honestly don't know what this looks like on Mac. I've never owned a Mac. So sorry for, it's pretty much the same thing?
Yeah.
Okay, that's good.
You just double click it.
All right, sounds great. So for those of you running through this, you'll have this .zip file. You'll just simply extract that file out into whatever directory you happen to want to save this into. And then as soon as you do that, you'll have a folder. Within that folder will be your Godot game engine, and you're ready to go. And so if you could just double click on that extracted game engine file, has kind of this like robot icon, right? We'll start with step 2 of our project, the project setup. So whenever you open Godot for the first time, you're going to be greeted with a little menu that looks like this. This is essentially just kind of Godot's equivalent of the Unity Hub, where you can just kind of see all your various different projects. You can create new projects, and yeah, just kind of a little dashboard for all the various different things you have going on. What we're going to do is we're going to create a new project. So if you just select that button from the right-hand side of your panel, you'll be presented with this. You're just simply going to name your project. For the sake of this tutorial, I believe we name it like GDA _ platformer, but you can name it whatever you want. And then just simply define your project path. So that'll be just where you're going to save this project to. And then as soon as you've defined both of those, you're just going to, well, you have the browse button, right? I'm sure you guys can figure that out. And then you'll open directory. You can create a folder. In this case, we suggest that you create a folder called Godot project. You do not have to do this. You can save it wherever you want to, right? Call it whatever you want as well. But you'll just select that folder, define your path, and then define your name. And you'll click create and edit. So I'll just go ahead and run through those steps real quick, just for anyone who, I don't know, just wants to see it done. So I'm going to define a new project. I'll just name this My Platformer. Sure. And I actually want to save this to, yeah, I'm in documents, so that's why I'm confused. Okay. If I can spell desktop, and then I will just create a folder within my desktop, and I will just call it demo. Folder, create and edit, and Godot should hopefully boot up. So we'll just give that a second. Okay, so we have Godot for the first time. I'm not going to run through in very much detail on everything that we're looking at here, just simply due to time constraints, but just to give a very brief overview. So on the left-hand side, right, we have our node hierarchy. These are essentially the objects within our current game level. You can kind of think of it like that. We have this middle view, which is just essentially our like preview, where we can easily fly around our scene and just kind of look around, move some things around, change up some of our assets, just see how things are looking. We have in the bottom left corner our file system. This is where all of the files for our game are stored, whether it be assets or saved scenes, etc. And then on the far right-hand side, we have our inspector view, which is where we can see the various different properties, variables, and components that are on our objects. And so, yep. So we'll just hop back over into the slides and we'll just follow along that step. So now that we have our project created, we'll move on to step 3, which is tile set creation. So the first thing we have to do, right? So this view, default view, right? What we're going to do is we're going to come over here into the left-hand side where we have our node hierarchy. You're going to find the 2D scene node, which is at the very top. You'll select that. If you accidentally happen to have selected like a 3D node or any of the other variable nodes, right, you can just Control Z, not a big deal. But, right, we'll end up with this node 2D up here in the top left-hand corner. So what we're going to do is we're actually going to select our node 2D. We're going to select the plus arrow in the top left-hand corner, or you can right-click on it and select Create New Node. Doesn't really matter. And that will open up this new node panel. Within this new node panel, we're wanting to create a sprite object. The sprite object is what will allow us to actually render our little character, right? So we will just search that up, navigate to it, select the sprite object, and then select Create. And we will now have our sprite object within the left-hand side here. We're going to do that exact same thing now, right? So we're going to come back over here. This is just showcasing the right-hand version of this, right? Or the right-click version of this, right? So we're going to now create a subnode of the sprite. So we're going to right-click that, create a child node, or you can press the plus sign, doesn't really matter. And then in here, we're going to search up a static body. We have 3 different types of bodies. We have a rigid body, we have a static body, and a kinematic body. I'm not going to go too much in detail, but for the purpose of our tile set, we want it to be a static body, right? So we'll just create that. And now we should have a node 2D followed by a sprite, followed by our static rigid body 2D, right? And then finally, we're going to do it one more time, but this time we're going to select a collision shape 2D. We'll create that. And now we're left with these 4 different levels of nodes, right? That are all kind of subnodes of the parent node, which is node 2D, right? And so this will be the basis for our tile set, right? So what we're going to do now is we're going to go find our test floor panel, wherever you happen to have saved that asset. And then you're just going to simply drag that into the file view in the bottom left-hand corner. And that should import your tile set for you, right? And so I'm just going to give a couple minutes just in case anybody needs to catch up to this point. In fact, I guess I can go ahead and run through this for anyone who needs a little bit of review. So what I'm going to do is I'm going to come into Godot. I'm going to create a new 2D scene, add a child node of type sprite, add a child node of the sprite that is a static body, and add a child node of that called collision shape 2D. I have all of those. Oops, didn't mean to do that. Okay. And then I actually need to go grab my assets. So what I'm going to do is I'm actually going to hop over to where I shared that link with you all. So if we just follow into this assets link, it will open up this Google Drive folder, right? Where we have sprites and tiles. Currently we need the tile. So I'm just going to go ahead and just download that from this package. And then I will actually just navigate straight into my demo, and I will just save it directly inside of that folder. And in fact, I'm going to go ahead and do the same thing with the player tile, or not player tile, but the player sprite. And I will save it into the same folder so that I can access it later. Right? And so now if we navigate back into Godot, we should see that we not only have our sprite sheet, we also have our testfloor.png, right? So jumping back over into the slides. So right, in this step, we have just added our testfloor.png to our file view. And so now what we're going to do is we're actually going to apply that so that we can actually look at our sprite, right? Because right now it's kind of boring. We just have this empty world. So what we're going to do is we're going to select our sprite node. And then within the sprite node, what you'll notice is on the right-hand side here, there in the inspector view, there is this texture property. We're going to drag our testfloor.png all the way over there and drag it into that box that says empty on the right-hand side for the texture property. And so what that should do is you should notice that you now have an image for your little sprite, a little box. Isn't that neat? So your sprite might be a little fuzzy just simply because this was built with the idea of a pixel art game in mind. So what we're going to do is we're actually going to fix that, right? So we have this tab over here on the left-hand side where the scene view is that says import. We're simply going to select that, and you will be presented with this new view on the left-hand side where we previously had our scene hierarchy. Within that, we're going to just select our preset there, and we're specifically going to set the 2D pixel preset. And this will just essentially handle a lot of the import settings for our sprite. So that way our image comes across a lot more crisp and clear like it should in a true pixel art game. So we'll select that 2D pixel and we'll simply select re-import. So fantastic. So before we move on a little further, just as review, I'll come into my project and do the same. So I'm going to select my sprite node and drag that over into the texture property. I now have my sprite rendering. Oops, didn't mean to do that. And so now, just to make sure that my import settings are correct, I'm going to go to the import tab, going to select preset, followed by selecting this 2D pixel property. And then I'm simply going to select this re-import button. And that has just made sure that all of my import settings for my sprite are correct. So for those of you who might have used Unity in the past, you might remember having to set a whole lot of various different values for your pixel art within the Unity editor to try to make sure that it was the correct ratio and make sure that it was the correct size and everything was, you got compression and all sorts of stuff like that. Well, in this case, Godot will just handle it for us with the click of 2 buttons, which is pretty convenient. So now just hopping back over into the slideshow. What we're going to do now is we're actually going to define our collision shape, right? Because now we have the image, but it wouldn't make a whole lot of sense if we ran around our world and, you could clip through things and some objects had a bounding box that are bigger than the actual sprite that it's rendering. And so we're actually just going to make sure that we have a sprite shape around this so that in the future, whenever we try to collide with it, everything seems proper, right? So we'll select our collision shape 2D node. And then you'll notice the shape property in the right-hand side where there's currently an empty slot. We're going to select that and then just simply select a new rectangle shape 2D. That will create a rectangular shape around your object. You'll see that kind of blue box that's just appeared, right? And so once we have that, what we're going to do is we're just going to change a couple settings that will make our life easier up here. So with the collision shape 2D still selected, we're going to come up here and we're just going to simply select this little kind of grid with a magnet on it, right? And this will just essentially enable snapping to grid so that we don't have to guesstimate the boundaries. We can actually snap it. So yeah, just kind of a handy little tool that you can use for that. And so we'll select that. And then as you can see, there's the little orange circles in the corners. You're just going to drag those out until you have fit the bounding box of your shape or your sprite properly. And so now yet again, just to make sure that everyone is caught up. So we come into collision shape 2D. We'll go to our shape property. Inside of there, we want to define a new rectangle shape 2D. Once we have that, we should notice this new blue rectangle, or not rectangle, but box. And then what we're going to do is we're going to select this grid with a magnet on it just to enable snapping to grid. And then that will just make our lives easier for resizing this to the proper size of our sprite. Okay. So now that we have that set, let's head right back over to the slides and finish up creating our tile set. Right, so now we have our bounding box around our sprite and our sprite's rendering properly. So now all we got to do is we'll come in here. We're going to select a few more tools, right? We're going to select that same grid snapping tool. We'll select the one immediately to the left of it. And then we'll select one final tool off to the right-hand side of the little lock symbol. And so if you select all of these tools, this will help us out. So you're going to go into your scene tab in the top left corner. Once you select that, you're going to go to convert to, and this is where we're actually going to convert our little sprite node into its actual tile set asset. And so we're going to select convert to. We'll select the tile set. And then that should open up this new window that says export tile set, right? And we should be inside the root folder for our project. And so inside of here, you're going to ensure that the file type at the bottom is this .tres file type. And then you're going to name your file. In this case, we put GDA tiles, but just put anything that is descriptive and makes sense to you. So once you've inputted that, we're going to click this save button. And then what we should notice, if you look in the bottom left-hand corner, we now have our GDA tiles.tres, right? So we have successfully created our tile. And so once again, I'm going to hop over into Godot so that we can run through all that again, just as a little bit of a review. So we have all this. We're just going to select those tools. I already have this selected from before, so I don't have to select it again. And I select that, right? And now that I have all that set up, I'm going to come over here to my scene view. I'm going to come down to the Convert To tab. I'm going to select the Tile Set option. Once I'm in here, I'm going to firstly ensure that I have this .tres file type selected. So I'm just going to click this drop down and select .tres. And then I'm just going to name mine to the thing that we have for the tutorial, GDA_tiles. And so once I have that named, I'm just simply going to select this save option here. And then what we have now is we have this GDA tiles.tres object within our project view. So cool, we've created a tile. So now we probably want to actually use that tile to paint our world and actually fill it up with this beautiful, beautiful orange and gray square. So hopping right back over, just so that we can get a detailed breakdown of what that's going to look like. This is the last thing that we did. Okay. So now what we're going to do is we're actually going to set up our main scene, right? And so this is just going to be kind of our test scene for us to run around and actually set up our platform mechanics. So what we're going to start with is, now that you've done this, you're free to save your tile map scene if you make any final changes to it, right? And then what we're going to do is we're going to come up to the scene tab at the top left-hand corner. Once we get that drop down, we're going to select new scene. And that will bring us back to a very similar view to what we had whenever we originally opened our Godot project. And so once again, because we're working in a 2D platformer here, we're going to select the 2D scene node. And that will simply create our kind of root node for this scene, right? For this node, I believe we're going to rename it to main, right? Just to kind of solidify it as the root node for the world. And once we've named it as main, we're wanting to now create a new child node. So that way we can actually use our tile set from before, right? And so we're going to add a child node. And then we're going to search up the tile map node. We're going to select that and just go ahead and create our tile map. So fantastic. And then in the right-hand corner, you'll notice that there is a tile set property. We're just simply going to drag that tile over into our tile set property. So that way we can essentially set our palette that we will use to paint our world. And so once you've done that, we now have GDA tiles selected for our tile map. and you are free to paint your world as you wish. little joke there. Okay, so these are just some quick tips for tile map drawing just to make your life a little easier for some of the maps that you might want to do, right? So left click is to paint and right click is to erase, right? So a little animation to show you what that looks like. If you hold left click and space, you can zoom in and out of your scene camera. So in case you need to, get really close to something in your world, or in case you want to like zoom out so that you can get a perspective of what things are kind of turning out like. If you hold left click and shift, you can create as straight of a line as you possibly can using tiles, right? And so you will hold that and just drag it around until you find the other end of the straight line that you want to draw, and you'll just deselect that and your line of tiles should appear. Keep in mind that for most of these tips, you can also use them to delete as well. So if you want to like carve out a straight line of some kind, right? Left click plus shift and control will allow you to draw out huge boxes, right? And so now we'll give you guys just a little bit of time to build out your test scene so that way we can actually have our character run around within it here in a moment. And so I will actually get caught up to speed with you, and hopefully we should be good to go. So I'm going to come into here. I'm going to create a new 2D scene. Like we did in the tutorial, I'll just rename it to main so I can define it as my root node. Add a child node called a tile map. And then I'm going to drag my GDA tiles into that tile set property, which now has defined that. And you'll notice that I now have this little box that follows me. And if I hold down left click, I can paint. And if I hold down right click, I can erase, right? It's kind of like just drawing in a normal application. So what I'm going to set up is just a pretty boring straight line. And I'll just add like a little hump here, like a kind of staircase. Maybe I'll add a cool platform there. Maybe another one there. And then maybe I want to build like a wall around my level so that my player just can't fall out of the world. There we go. It's a beautiful level. It's perfect. This is expert game design. Yeah. I will give you guys just a moment to finish up drawing up your world, and then we will carry on to the next step of our tutorial, which should be implementing our actual character into the world. Exciting. So I'll just give a couple more minutes for that. So we'll just pause on the screen. Just let you guys have fun creating your kind of test case that you'll be using to play around and have fun with your first video game. Okay, so you should be finishing up drawing your small little test world, so that way we can move on. So now we're going to move on to step 5, which is player setup. We're almost there to the end of our complete 2D platformer. And what, it's only been 30 minutes? Yeah. So we're going to start by going to our main node here, and we're actually going to create a new child node of that. So if you just right click or select the plus button, whatever you prefer, to create a new child node, This time we're going to create a kinematic body 2D. And so just to distinguish so that we have a little bit of compare and contrast between these two types of bodies, before, whenever we created our tile set property, right, our tile set sprite, we use the static body. And the reason that is that with a static body, you don't really want it to interact with the physical world, right? Like you don't want to be able to like kick a wall out or have the floor just completely disappear in these cases. You want them to remain in place. However, you still want collisions to occur. You still want friction to be applied, right? You still want all the physical properties that you would get. You just simply don't want that object to move. And so contrast that with a kinematic body. A kinematic body is essentially a body that we want to define the movement for. So we still want it to collide. We still want it to interact with all the other physics objects within our world, right? So maybe we put a ball in our game, or maybe we have some kind of pushable block or something like that, right? So we want our body to still interact with the physics system of our game. However, we want to be able to define the movement so that it's not just kind of, flopping around, just having gravity and whatever other forces have its way with it. So we're going to create our kinematic body 2D. And so now you should have two different subnodes of that main node. You have your tile map and your kinematic body 2D. We're just simply going to rename that to player. Player is a pretty descriptive name, just so that whenever we're looking through here, it's a lot easier to distinguish that, right? And so what we're going to do now is we're going to add a sprite node like we did with the tile map, so that way we can actually render our character. We're going to add a collision node. So we're going to also use a collision shape 2D as we did for the tile map. We're also going to add a camera node, right? Because whenever our player is moving around the scene, we want the camera to follow them. It would be, for our purposes anyway, kind of weird if the camera, just stayed in one static spot and our player was able to just run off and do whatever within the map. So we're going to add a camera node. So in this case, a camera 2D. And then we're going to import our sprite sheet, right? So if you haven't done this before, as I did in the step prior, what you're going to do is find wherever you save that sprite sheet from the assets folder, and you're just going to simply drag that right into the file system view in the bottom left corner of the screen. And as soon as you do that, it should import that into your project. So I know that was a lot to go through. So just for review's sake, before we lose anyone, I'm going to come back into my Godot project, right? I'm going to come to my main node. And the first thing I want to do is I want to add a child node of my main node called a kinematic body 2D. And once I add that, I want to rename that kinematic body 2D to player, just simply so it's easier for me to find my player in the future within my scene. Next, we're going to add 3 different nodes to this. The first of which is going to be a sprite node so that we can actually render our player. So we'll just create that. Next is our collision shape, so that our player can actually collide with the other physics objects within the world. So we'll just add that collision shape 2D. And then finally, we're going to add our camera 2D, so that way we don't lose our player as they move around the scene, right? And then for those of you who may not have done it already, right? So we imported our sprite sheet for our player from that assets folder from before. So here it is, fantastic. And then actually something that is not included in the slides that we're just going to go ahead and do real quick just to ensure that our sprites look crisp and clear like they should in a pixel art game is we're just going to make sure that our import settings are correct, right? So we're going to select our 2D sprite. We're going to go to its import settings by selecting that import tab in the top left corner. Yet again, we'll select this preset button here next to the texture dropdown. Inside of there is a 2D pixel preset that Godot has provided for us. So you'll just go ahead and select that. And once you have, you will select the re-import button at the bottom of the screen just to make sure that we're applying all those properties to our sprite. So that way everything should look really crisp, clean, and everything looks, properly like pixel art instead of having a lot of blurred effects or weird scaling issues, right? So now that we've done that, we're going to hop right on back over into our tutorial to finish up with the planner. So we imported our sprite sheet. So now we're going to select our sprite node, and we're just going to drag that sprite sheet all the way over into the texture box, right? And so what you're going to notice is when you do that, you get the whole sprite sheet, right? Oh, actually it was included. I didn't know that it was in here. So this step is just going through what we just did before with the sprite sheet, where we went to the import settings, made sure that the preset was 2D pixel, just as a review, I suppose, and then select re-import, right? So a sprite sheet is essentially a collection of different pictures of our sprite, right? That we would like to define as the frames of some sort of animation for our 2D object, right? So in this case, we have the various different phases of our run cycle, right? Where our player is kind of pumping their arms and swinging their legs. And at the end of it, we should create, if we play it properly, right, all together, we should create this animation that we see at the top there, right? Now, one thing that you will notice is missing is number 1 over there. That's actually going to be our idle state. So just for kind of standing around and waiting. But anyways, so to carry on from that, this is just some example of walk cycles. So to carry on from that, what we have is in the right-hand side here, inside of our inspector view, if we're still selecting the sprite node, there is a animation tab. You're simply going to select that to drop down all these various different tasks. What we're going to do is adjust the H frames to 9. The reason that we adjust it to 9 is because we have 9 frames within our sprite sheet, right? And so when we do that, we should notice that all that compresses and all we get is a single frame of our animation, or of our sprite sheet rather yet, showing at a time. So the next thing we're going to do is we're going to select our collision shape 2D. We're going to go to the shape property and select that drop down, and we will do a new capsule shape 2D. So this is just simply so that it fits a little better around the bounds of our player than what a box otherwise might have, right? So once you select that new capsule shape 2D, then you'll notice that we have the little kind of cyan box right in the middle of our thing. Well, cyan bean, more like. And so what we'll do is we'll just drag the bounding positions of that to match kind of the size of our player, right? And so just to be sure that we're not losing anybody, I will go back and do these steps. So we go into sprite, and then inside of our texture, we're going to drag in our entire sprite set, and we get all these various different frames, right? Well, we don't want all these frames, and so what we're going to do is we'll go to this animation drop-down window, and because I know that there's 9 frames within my animation here, specifically 9 in the horizontal direction, if you were to stack these vertically, right, all you would do is change the V frames, or if you made some sort of like matrix of various different animations, then you would just adjust the H and the V, right? But in this case, we only have H, so we're just going to adjust that to 9, and voila, we have everything. I keep trying to press Control S out of habit. Which I suppose that's not a problem, right? So we can actually go ahead and just do that so that it doesn't cause a problem in the future. If you select Control S, or if you try to save your scene, right, you'll come into here. We can actually just save our main scene within the root folder of our project. So if we click save, you should notice that there's now main.tscn. Right, and so that's just essentially saving our level for us, right? I'm going to do a little bit of finagling because I didn't quite get the size of my map to where I would want it for the size of my player, right? So I'm just going to do a little bit of changing by selecting my tile map and just adjusting a couple things, just so it's easier for me to test here in a moment. Now I'm going to select my collision shape 2D. And as we did in the slides, we'll come to the shape property. And within that dropdown, we're going to select new capsule shape 2D. Then we can simply zoom into our player to notice this kind of blue bean. We're just going to drag the boundaries of our blue bean to match as closely as we can to our player. Yeah, that's not bad. That's pretty good. So that's about the bounds that I'm going to use. Something else I'm going to do, if for whatever reason, right, your map and your player happen to have a tile in the same location, right? So we have our player currently like halfway through this little box here in my case. What you can do to fix that, right, is we can actually move our player. And so to do that, you can come into the player and you could either select this tool up here, which would allow you to just move him around, right? So I'll just move him here. But if you want more precise control over the position of your player, all you simply have to do is come into the root node of your player that we named player at the beginning, find the node 2D column or component here on the right-hand side in the inspector view. And then you'll see that there's this property called transform. So if you drop that down, there's this position. And since we're working in 2D, we have an X and a Y value. That just allows you to more precisely control the position of your player if, for whatever reason, you just want to work in more exact numbers, right? Okay, we're almost done, I promise. So, right, so we selected our thing, we added our bounds. So now that we have that, what we need to do is we're going to go to our camera 2D, and there is a property within there called current. What we're going to do is select that on, right? And this will select that camera as our current camera. Then we're going to apply some smoothing values, right? So what we're going to do for that is we're going to select this smoothing dropdown that we have. Within that, we're going to make sure that that is enabled. That's essentially just going to make sure that our camera is not just rigidly snapping to the position of where our player is, right? And then once we have that, our camera should, in theory, once we get the movement set up, follow our player very smoothly so that it doesn't just snap to the position of where the player is in the world. So this could be good if you want, to like exaggerate some of the movement of the player, right? So like the player is getting faster, and so they're closer to the right-hand border of the screen, right? Stuff like that. Just kind of invigorates that game feel. Once we get done doing that, we're going to select our player node. And then what we're actually doing here, I believe, is just saving our node. Oh, nope, we're doing something else. So we're going to click this, the same component as we selected before whenever we were working with our tile set, on the right-hand side of our kind of lock symbol at the top hand of the screen. Once you have that selected, you're going to select the scene in the top left corner, and then you're going to save the scene. So you'll just do that. Actually, it did walk through the exact same thing that we did. Never mind. I thought it was going to do something else. But yeah, essentially just saving your scene. So just to finish up with step 5, with the smoothing of the camera and setting our camera as our current, we come in here to our camera 2D. There's a property within here that is called current. This will just simply select this as our current camera. And then we have a smoothing drop down that we can enable. and we'll just leave the default values for that for now. Okay. And if you've made it to this point, you have completed step 5, and we should be on the home stretch to having a completed 2D platformer game. So I'll try to move through this a little quicker because we're just over the hour mark now, I believe. So we're going to do a little bit of input mapping, right? So what you're going to do is you're going to go to the project tab in the top left-hand corner right next to your scene tab. You're going to drop that down and go into your project settings. When you select your project settings, it should open up a panel that looks like this. Within here, you're going to find the input map tab at the top of the screen. If you follow that tab, you'll come into a whole list of various different mappings, right? This is essentially, for those of you who have used Unity in the past, this is essentially Godot's equivalent to the Unity input system, where we have various different axes and buttons defined, right? It works a little differently, and we'll get into that, especially whenever we touch on the code. But what we're going to do is you can just search action left, right, jump, and you can just add all of those actions, right? And so now you have a collection of left, right, and jump. That's essentially all that we need. Need to move left, right, and jump. And so then what we're going to do is on the right-hand side of each of these, there is a plus icon. If you click that, it should open up this little menu. You're going to select the key, right? And so this is so that we can assign a key to that action. And then you'll click whatever key you want to be your left key. In my case, I'm going to use WASD, well, I suppose A and D, left and right, right? And then I'm going to use space for my jump key. But if you have some other configuration that you are just absolutely in love with, you want your G key to be your left key and you want your P key to be your right key, I don't care. You can do it. So once you set your key bind for each of those, right? So this is just kind of the setup that we'll be using. By the way, this also demonstrates that you can map multiple different keys to the same action, right? So maybe you want WASD to work at the same time as you want your arrow keys to work. This is essentially just demonstrating the fact that you can just repeat this process for all of these things until you have all the proper key bindings set up, right? So now I'm going to go into my project just to ensure that we haven't lost anybody and catch up. So I go into project, I'll go into project settings. From there, I will follow into my input map. Inside of my input map at the very top of the screen, I'm going to define 3 different actions. Left, I'll click add. Right, I'll click add. And jump, I'll click add. I have left, right, jump, the very fundamentals for my platformer input. And then I'm just going to select these plus buttons, select key, and then the key that I want to define that. So, right, I want the A key to define left. For my right key, I want to define D. For my jump key, I want to define space. And then for my right key, I also want to define the right arrow. And for my left key, I also want to define the left arrow. So I'm just going to go through and set all of these different key bindings just so that I have something that I can reference here in a minute whenever we do a little bit of scripting to set up our platformer movement. So, okay, once you have that, you should be able to just close out of that and you're ready to go. You should have all of your input mapped. So now moving on, right? We have all of those. We're going to move on to step 7, which is our player movement script. To make our player movement script, right, you're going to select your player node, and then we're going to attach a script. So if you look at the top of your scene hierarchy, where the plus button is, where we've been selecting to add a child node, on the far right-hand side of that, there is this plus with kind of a piece of paper next to it. That is how we're going to add a script. So like I said, make sure that your player node is selected, and then select this attach script button. You can name this script whatever you want, right? And you can also define the path. If you want to create a folder, especially for your scripts, This is where you could kind of select to do that. But in our case, we're just going to rename this to, in this case, we renamed it to player. I'm personally going to rename it to movement, right? And then once we do that, we should get this new view that looks like a regular old IDE. At the very top of our screen, if for whatever reason this did not switch for you, you'll notice that there is a 2D, 3D script and then asset library. You can just simply select the script view and then just, double click your saved .gd file if for whatever reason it's just not appearing, right? And so once we have this, what we're going to do is we're going to declare a little bit. So we're going to just wipe out these default comments that are within the default script. And we're going to also wipe out these default comments until we're just left with the ready function. Okay. So now we're just going to create a little bit of space here, right? Now what we're going to do is we're going to declare a few variables, right? And so the first one is going to be this var called speed. And we're just going to set that to 500 as our value. You can tamper with this value later to see what you like. But for starters, you can just trust us with speed, right? Now we're also going to select or set our variables for gravity and our variables for our jump force, right? And so we're going to do that by creating another couple of variables the exact same way. We're going to set our gravity variable to 2000 and our jump variable to 900. Right? And then finally, we're going to define a velocity vector by doing the exact same thing. We'll define var velocity and we'll just set that equal to a vector2.0. And we'll also define a motion vector, which will be called var motion. And we'll just set that equal by default to just a vector2, which will declare basically a vector2.0, right? Okay. And so this is just kind of outlining a little bit of the code here, right? So you can just basically for now ignore the stuff that's in yellow. We haven't really gone through that yet. But the stuff that is in purple, you definitely need to declare. And then the stuff that's red is some explorative variables that you could define to better enhance the movement system later on. But for now, for the purposes of a beginner tutorial, just focus on the stuff that's in purple. So now that you have all that, right, what we're going to do is we're going to come down below our function ready. You don't necessarily have to be below function ready. We're just doing this simply because, we got to go somewhere and we're just going to go down for pure readability sake, right? And so we're going to define this new function that is a default function within Godot called _physics_process. And then we're going to have a delta argument passed to this. So we're going to just open parentheses. Within those two parentheses, you'll just type in delta. And at the very end, you will just simply add a little colon to open up your function. Cool. So a little note at the bottom right of the corner is to take note of indentions. GD script is indention sensitive, right? So in prior languages, right, some of you may have used Java or C++ and such like that, where you have like curly brackets that defines kind of like the body of a method and the like body of a switch statement or a for loop and so on and so forth like that. Here, GD script is specifically indentation sensitive. So you can kind of notice where at the very top of the screen, right, you see that function ready. And then below that, there's like that little arrow that's kind of like grayed out a little bit. That's essentially just denoting that there's one indentation there. And then we just have pass, right? And so that's the body of that function. right? But what we're going to do within our physics process is we're going to define our velocity.x to be equal to 0. We'll set our velocity.y equal to, or plus equals, rather yet, to gravity multiplied by delta. Essentially what we're doing is we're adding our gravity, and then delta, I won't get into a whole lot, but essentially delta is a value that we're using to keep our game frame rate independent, right? So if our game's running at 60 frames per second, or if our game is running at 2 frames per second, the speed value should be relatively the same either way. That's just essentially a way for us to control how a game functions on both fantastically amazing hardware and hardware that's not so much, right? So once you have that set up, we'll create a little simple if statement here. So you'll do if input dot is underscore action underscore pressed. So input is a class within GDScript that we can call the method is action pressed. And you'll remember from before the key bindings that we made, we're going to pass a string value by opening up those quotations. And in between quotations, we will type in the string values left. And then in the else if, denoted here by elif, we'll do input dot is action pressed for the right-hand side, right? So left, right. Now, something that could be denoted here, in this case, we have written velocity.x plus equals negative speed and velocity.x plus equals speed, right? And there's definitely ways to optimize this code. This is very beginner friendly, so we're just kind of working on some very simple assumptions. This may be your first time coding, right? But something to denote is you could just leave speed the same in both of those, so removing the negative sign and simply moving the subtraction into where that plus sign is and the plus equals, right? So you could do a minus equals for negative as well, right? And so just to review a little bit before we go too much further, right? So what we've done so far is we've selected our root node. We've attached a script by selecting this little like piece of paper with a plus sign. We've created a new script. In my case, I'm going to call it movement.gd. And so we've started with this. Whenever we started out with this program, we just went ahead and wiped away some of the default comments that are within our code. By the way, at any time, you can just press Control S to save. I would recommend that being a habit. And then we started by declaring a series of variables, which I may have to go back to the slides to actually reference what those values should be. But if I'm remembering correctly, we had at first a var speed, which was equal to 500, which I could be wrong. Then we had our y direction variables. So we had var gravity, which I believe was equal to 2000. And getting a little bit of case there. And then we had a var jump, which was equal to, how much was var jump equal to? 900? I don't know. I'll go back and check the values here in a minute just to be safe. And then we declared a couple of vectors. So we had var velocity. We just set that by default to be equal to a vector 2 dot 0, right? And then we also had a var motion, which we set equal to a vector 2, vector 2, if I could write. And then we just open and close these parentheses to essentially just create a brand new vector with nothing assigned to those x and y values, right? Once we've done that, we came below our function ready, and we defined a new func. And we called it underscore physics process underscore physics underscore process open close delta, right? Okay, we're getting a little bit of an error here, but that's just because we haven't defined the body yet. So if you see that, don't be scared. Whenever we enter down, we now have our body of our function. So what we did in here first is we did velocity. So referencing that variable that we created at the very beginning of our script. And because velocity is a vector, and specifically a vector in the second dimension, we have an x value and a y value for our vector. So we do a dot x, and we just set it equal to 0 by default. Essentially, velocity is taking the place of an input vector, right? And we'll do velocity dot y, and we set it equal to gravity multiplied by delta, right? So we're just applying gravity in the downwards direction, right? Which inside of Godot, something to mention, down is positive, up is negative. Yeah, we're making Minecraft 3. So anyways, we define those. And then we define a very simple if statement, which is input dot is underscore action pressed. And then within that, we're going to write left. And within our indentation here, what we're actually going to do is our velocity dot x. In the x direction, right is still positive, left is still negative. But for some reason, we just decided to flip the y value so that we can confuse you. And then we do a minus equals speed. And we're going to denote a elif. Oop, if I can write it. Input dot is action. Whoops, not just pressed. Pressed. And I want to do right. And then we do the same thing with velocity dot x, but this time we're going to plus equals speed. Okay.
Wait.
What is it?
You know what it means, guys.
Oh, wow. We're having a great time. Having a great time. Making memories.
I started looking up that because I was like, you make me watch Godot.
Yeah. I mean, they're just that interested, right? It's kind of cool, right? They want to make games.
I would think totally more than I thought it was new. I had it taken care of.
Yeah. So I believe part of the issue here, and I'm just going to make sure that I'm correct by running through the code. So I can actually check. Yeah. Nope. I'm going to go back to just make sure. So 2,900. Yep. Just making sure that all my values were correct. Okay. So we run through this input is. And so we have velocity.x plus equals negative speed plus equals speed. And then finally, we have one final check, which is if input.is action just press. This one's a little different, right? Essentially, all we're checking for is the initial press. We don't care if you're holding it down. We just want to know, did you press it at all? And inside that, we're wanting to check our jump button that we've defined. And inside of there, we're just going to have another if statement that checks to see if we're on the floor. So if is underscore on underscore floor, open close parentheses. And if we aren't, or if we are on the floor rather yet, then we're going to set our velocity dot y equal to negative jump, right? So what that essentially does is just kind of overriding the gravity value that we set before, and it's just throwing us upwards. Okay, cool. And then we're going to do one final thing where we set our velocity equal to this wonderful built-in function called move and slide. Essentially, this will help us to move around our scene and also collide with physics objects within the world. And then to that method, we're going to pass two different things. We'll pass our current velocity value, and then we're going to pass, by separating via a comma, our vector2 dot up value. So I'll just give a moment for anyone that needs to like read through the code. Okay. So yet again, this is just kind of showing you some things that you could look into. Oops. Showing you the things that you don't really need to take note of, but for the purposes of this beginner tutorial, just focus on the purple yet again. So by the end of your code, this is what the entire script should look like, right? So now that we've done that, what we're going to do is we're going to navigate to the top right-hand corner where there is this play button. We're going to click on that. We'll select this button that comes up that says Select Current. Step 8, player animation. Well, what should have happened there is you should have played your game, but we didn't show that. So we'll show that in Godot because that's more fun, right? Okay, so we'll just finalize a little bit of this. So we have that opened up. Velocity. Yeah, I misspelled it. I added a C in there. I was like, Okay. And then we come down and we do our if statement for input dot is action just pressed for our jump. And then if it is, then we want to check if is underscore on floor. And if that is also true, then finally we want to define our velocity dot y to equal negative jump. And because that indentation is going to bother me, there we go. So finally, we just do the final bit of code here where we call this, or actually we need to set our velocity equal to move underscore and slide, where we pass velocity and we also pass vector2 dot up. Oh, that's going to bother me. Actually, I think that would cause an issue. So there we go. Let's make sure all the indentation is correct. So we're at the end of our code. I'll just give a second for anybody that might need to catch up. We'll go to play, select current. And then what happens is we open up this menu. Our player kind of, if we press space, kind of like jitters up, right? But if we press left and right, we can actually move around our scene. So kind of lackluster at the moment, right? Because we just have this static player that's moving around and the jump isn't that impressive, right? Because he's got like a 3-inch vertical, right? So. Oh, it's not working? So actually we'll do a little bit of live debug.
Yeah.
Yeah.
So we'll go figure out why that is. So let's see, we have our physics underscore process delta. So it's not throwing you an error, right? I know why. Oh, never mind. I don't know why. I thought I knew why.
Yeah.
So you got speed, gravity, jump,
Yeah.
velocity, motion, cool. Everything's running through. Everything's good. Velocity dot x is 0. Doing gravity. Left, negative, right, positive. Okay, so what tends to be the issue?
Nothing. Oh, I did it. These 2 buttons and over here. Now I can go back. And it looks to the wall.
Okay. So let's just check your keybinds within the project settings real quick to be sure they're correct. So if you come down, you have enter selected as your right
Oh.
button and enter selected as your left.
What? How did I do that? Right? Okay. Oh,
So
oh, I
hopefully that's-
pressed enter. Oh my
Yeah.
God. I was like, what? It's not working. Okay. Thank you.
Yeah, if you have any further issues with that, you can just go back in there, recheck your key bindings, make sure.
Yay. Thank you.
Yeah, no problem.
Oh, yay, it's working.
We made a platformer.
Wow. I made a platformer. Yay.
So something we can do about this tiny 2-inch vertical, just so that we can end today's tutorial on a nice note. We probably won't move on to the animation because it's already been an hour and a half. And yeah, I don't want to waste too much of your time. But just to finish up here, right, we have this little tiny 2-inch vertical. What we can do to fix that is we can come up here to our gravity value and our jump values, and you can just play around with what those values are, right? So I want my guy to have a super jump, and I want moon gravity. Let's see what happens with that, right? So we fall stupidly slow because moon gravity, and we just get kind of like a jitter up. So obviously there's a much better way to do this. You can play around with those values. You can play around with your code here to try to produce some better results. But yeah, so actually I'm going to set my gravity probably back to 3,000, I think. And then for my jump, I want probably about 1,500. But
You're setting velocity on y equal to gravity. If you were to add that instead, plus equals, that would make it accelerate.
yes, it would. Then you would need to limit it, right?
Well, yeah.
Unless you just want like infinite velocity or infinite infinite velocity eventually, right?
Set it to 0 when it's on the floor.
You certainly could. Yeah.
You want to do that.
Yeah, absolutely. So what Xander was suggesting is a way that we could improve this code is that we could just change this velocity.y equals gravity times delta, right? And what we could actually do is add gravity, right? And so essentially what that would do is it would make our gravity value essentially kind of like an acceleration almost, so that we're constantly changing our velocity at that rate. And so actually, if you want to play around with that, you can just add that plus there and just kind of come down here to this if is on floor. Or
You don't actually need to do that because you're setting
Yeah.
velocity to
Yeah, so we should be good there. I probably need to lower this gravity value though if I'm going to do this. So I'll just set it to like 500. But yeah, feel free to play around with those values, right? But like, look at that, right? Now we're actually getting some acceleration. Isn't that kind of fun? Moon gravity with a pretty cool acceleration. Now, unfortunately, we don't have very much time left, so I'm not going to get into animations. But for those of you who have been following along, thank you. If you would like a little bit more information about game development, please feel free to either follow GDA on social media, or you could join our Discord server where we post our weekly meeting information. We do weekly tutorials such as this one that go a little bit more in depth into the processes. We also do some analyses. We've been playing around with quite a few other different projects. So if you're interested in game development and those sorts of things, please feel free to stop by. But with that being said, we thank you guys for your time. I'm sorry that we didn't get all the way through the tutorial, but yeah, just play around that, iterate on that. Try to improve the code, make it work a little better, maybe implement some personal mechanics that you want to see. Maybe you want like a dash mechanic or a sprint mechanic, right? But just iterate on top of that, and you should have a pretty cool game. So thank you guys for stopping by, and we'll hopefully see you later.